Hello, this is Jack Jackson. This is the first of a series of videos going over some review exercises for this playlist for Unit 3 of Probability and Statistics. And basically I'm going to make a little video for each of these 17 problems. So the way this is going to work is you'll be given a exercise like this one, and one slide will be the exercise and the next slide or slides will be the answers. You should always pause the video after you're on the slide with the question, work the question out completely, and after you've got the answer, then press play to go on and see my solutions. So this first exercise says, carefully describe characteristics of the graphs of the probability density function, PDF, and cumulative density function, CDF, for continuous distributions. So we're talking about these properties in general. Explain how these properties are, how probabilities are illustrated on the graphs of both the PDF and the CDF. And what can you find using a CDF which you cannot easily find directly from a PDF, and vice versa, what can you find using a PDF which you cannot find directly from a CDF? And see if you can come up with answers for these questions. Press pause now. Well, here are the answers. Hopefully you've worked through this and written these down yourself. On the probability density function, PDF, for a continuous distribution, the graph of the PDF is always above or on the x-axis. In other words, the output is always a positive or zero output. It is on the x-axis, or it approaches it asymptotically on both the extreme right and extreme left. The probabilities can be illustrated as areas between the PDF graph and the x-axis, and the total area between the x-axis and the PDF graph is 1. To get probabilities, the probability that x is between a and b, we sum up the values of the PDF of x dx, which is summed up in the continuous case by what we call a definite integral. That's just long skinny s. And of course, remember, we have a calculator program built in that basically does that for us, at least approximately. We can compute the mean and standard deviation from the PDF, but we can't get these from the CDF. So this is really the big advantage of the PDF, other than it gives us a nice visual of area as probability. We can do probabilities from PDF or CDF, but the mean, we need the PDF formula. So the mean is you sum up all of the x times the PDFs. So you do x times PDF dx, integrate from over all x is negative infinity to infinity. For the standard deviation, once we've found the mean, we take x minus the mean, square it, multiply by the PDF, sum that up over all of the possible x values, and that gives you the variance. Take the square root of that for the standard deviation. And again, we can do this with our calculator. If we know the PDF formula, we can at least get a good approximation of the mean and standard deviation that way. Now the cumulative density function actually is maybe a little easier to work with. The graph of the CDF is always above or on the x-axis. The CDF graph is on or approaches the x-axis on the extreme left, and approaches or is on the horizontal line y equals 1 on the far right. The CDF graph is continuous, meaning it's one connected piece, and is non-decreasing, so it never comes down. It always stays either level or rises, increases, and eventually rises from y equals 0 to y equals 1. The y values of the CDF are actually cumulative probabilities. Okay, so that is the probability that x is less than a is equal to the CDF value. Probabilities can be illustrated as vertical distances on the CDF graph. Again, the distance from the graph down to the x-axis is the probability to the left. The distance from the graph up to the y equals 1 is the probability to the right. And the distance between two y values vertically is the probability between two. And we can see that is the probability that a is less than x, which is less than b, is just the difference in the two y values on the CDF curve. It's CDF of b minus CDF of a. Now we can easily compute probabilities using the CDF or the PDF, although it's a little easier with the CDF. But we can also compute inverse probabilities using the CDF, which we cannot directly do with the PDF graph. our formula. So the way to do inverse probabilities is basically what you're doing is you're taking the CDF here of A as the probability to the left, substituting in the known value for the left side of this equation, and then we have to solve for the A. A way to do that graphically on our calculator is to graph a horizontal line at the whatever this probability is, which is the probability to the left of the A value, and calculate the intersection of that with the CDF graph, and that gives us the X value of that intersection is then the A value that we're looking for. So those are the basic characteristics of probability density functions and cumulative density functions for continuous distributions.